Okay, here we go. So in this example, 7.2, we're going to simplify rational expression. In our rational expression that we are simplifying is x squared plus 5x plus 6, and that is all over x squared plus 8x plus 12. Okay, and this is actually part 1 of this question. Part 1. There's a part 2. So first we're going to simplify. Okay? So, take a moment to think about this. All right, these both look factorable, don't they? Something we may know how to do. Okay, so what you're going to do is you're going to factor separately. Factor separately. So x squared plus 5x plus 6. That's, we need two things that multiply to be 6, add to be 5. So those factor to x plus 3 times x plus 2. Here, we've got x squared plus 8x plus 12. We need two things that multiply to be 12, add to be 8. I'm not so sure, so I'm going to go over here. Multiply to be 12, add to be 8. We got 1 times 12, that adds to be 13, so that's no good. We've got 3 times 4, that adds to be 7, that's no good. Okay, so we got 2 times 6, that adds to be 8. There's our numbers. We can jump to our factors. We got x plus 6 times x plus 2. Okay, and now, after you factored separately, bring them back together. Bring them back together. So here's our top equation. X plus 3 times x plus 2. And that is all over. X plus 6 times x plus 2. All right. Now at this stage, we're going to cancel some things. Okay. So we look here, x plus 3. We don't see any x plus 3s on the bottom. So x plus 3 sticks around. But x plus 2, we've got an x plus 2 on the top and an x plus 2 on the bottom. So those can both be canceled. Okay, so what are we left with? X plus 3 over x plus 6. Okay, so that is your answer. This is simplifies to this, okay? But these fractions, they are equivalent, okay? They're equivalent, but not the same. They're equivalent, but they are not the same. Okay, so, but what do I mean by this? Okay, what I mean is when you plug a value into here, you're going to get an answer. And you plug the same value into here, you're going to get a different answer. Okay, so let's try it. Let's test it. So let's write our expression. So we have x plus 3, x plus 2, and then we have x plus 6, and x plus 2. Okay, and then here we have x plus 3 over x plus 6. All right, we're going to plug in 1. We're going to plug in 1. So plug in 1 for both of these. All right, so up here we end up getting 4 times 3 over 7 times 3. Okay, so this actually equals 12 over 21, but you could probably see at this point what that's going to reduce to, 4 over 7. But it equals 12 over 21, which reduces to 4 over 7. Okay, so these are equivalent. Okay, so now when we plug this in, okay, you're going to see where that comes in to play. We plug 1 in, we get 4 over 7. So they're equal, but this fraction never equals 12 over 21, right? It skips right to 4 over 7. So these things are equivalent. They have the same value, but they're not exactly the same. Why does that matter? Well, let's do part 2. Let's do part 2. When is our expression undefined? When is our expression undefined? Well, what's our original expression? X squared plus 5x plus 6 over x squared plus 8x plus 12. So when is that expression undefined? The common mistake is to come here and use our answer and just say, oh, well, here's our answer. So don't we just set the bottom to be 0 and we get x plus 6 equals 0. Oh, x equals negative 6. This is only half our answer. This is only half our answer. So I'm going to cross it out and we're going to say that's wrong. You need to go back and you need to use this before we cancel these out when our original expression is still intact because of this right here. Okay? Because this is equivalent to what we had up here, but they're not the same. You need to use the expression before we cancel stuff. So let's write that down. We had x plus 3 times x plus 2, and that is over x plus 6 times x plus 2. So now we're going to set each of these equal to 0. So we got x plus 6 times x plus 2, and those are equal to 0. And we got x plus 6 equals 0. And over here we got x plus 2 equals 0. Then we solve. So x equals negative 6, x equals negative 2. Boom. That's your answer. Okay, so let's interpret that. We would say another way to say undefined is this value undefined, a 0 with a slash, at x equals negative 6, negative 2. Okay. Now let's try another example here. Example 7.4. 7.4. And this one we did today. Today is Tuesday. So we are going to simplify x squared minus 4x minus 32 over 64 minus x squared. Okay, so why this one's weird? Okay, take a minute, look at it, try and see if you can figure out what's different. Okay, so you might have noticed we have our x squared and it's a negative. Okay, we actually don't like that. I don't like x squared being a negative. So we're going to factor out a negative 1. Factor out a negative 1. So when we factor the negative 1 out of the bottom, the top stays the same. But now we got this negative 1 taken out of the bottom. When you take a negative 1 out of positive 64, it becomes a negative 64. And when you take negative 1 out of negative x squared, positive x squared. Okay? So at the next step, this negative 1, since it's being multiplied by the bottom, we can just pull it out front. Pull it out front. We got x squared minus 4x minus 32. And that is all over. Well, and now So this is what we have left on the bottom, and I'm going to rearrange them. So you got x squared minus 64. Okay, next step. This negative 1 can just become a negative sign, right? X squared minus 4x minus 32. Well, what multiplies to be negative 32 but adds to be negative 4? It's actually just going to be x minus 8 times x plus 4. And now here, these are both perfect squares, so the square root of 64 is 8. Square root of x squared is x. Therefore, my answer is going to be x minus 8 times x plus 8. Well, not my answer, but my factors. Okay, and now, as you can see here, we have some stuff we can cancel. So we have x minus 8 and the x minus 8. Cancel. Don't lose your negative along the way. And our final answer is negative x plus 4 over x plus 8. All right, so this is your answer. Okay. Be careful, okay? You can write your answer like this. You can also write your answer, you can distribute that negative throughout the top, so you can have a negative x minus a 4 over x plus 8, or you can also distribute it through the bottom, so you can have a negative x minus 8 with positive x plus 4 on top. Be very careful. Do not distribute this through the top and bottom. Let's see what happens if we do that. So if we had negative x minus 4 over negative x minus 8, and now we pull out a negative 1 out of both of those, we would get negative 1 times x plus 4, and then x plus 8. You see the negative 1s would cancel. We'd be left with x plus 4 over x plus 8, which is not that. So you can either leave it out front or distribute it through just the top or just the bottom, not both. All right, that's it for this video. Hope you enjoyed.